Greetings, this is Mr. Winter. I want to give you guys a little heads up on our next component for trig graphing. We've already talked about the A, which is your amplitude, which can be a stretch or compression. We've talked about how it reflects if it's negative. We've talked about the vertical shift, how it shifts up and down. We've talked about the phase shift, the horizontal shift. What we haven't talked about is the B, the frequency, which basically also results in a change of the period in the function. So follow along with me. I'm going to do a little bit on the graphing calculator to kind of show you specifically how the B works now that we know the other three components. So let me pull up a calculator here. I think I'm going to pull up a calculator. Okay, so first thing I'm going to do is check my mode. We are in radians. I'm going to go to my window. I'm just going to graph enough to see one cycle of the function. So I know that the regular parent function for like sines or cosines goes from 0 to 2 pi. Let me see, I believe that's pi, yeah. And the little grids I've been having you use, each little grid has been by pi over 4. So I'm going to have everything here go by pi over 4. And I know the sine and the cosine only go from -1 to 1. I guess I did something stupid here. Let's try this again. I want my x scale to go by the pi over 4. And again, like I said, since sine and cosine only go from -1 to 1, I'm just going to go from like -2 to 2. We don't need 10 or -10. And let's just take a good look at just the plain old sine function. Y equals sine of x. And once I graph that again, what do I see? Starts at 0, 0. This is pi over 4. Pi over 2, it's at 1. Pi, it's at 0. 3 pi over 2, it's at -1. And then back to 0 again at 2 pi. That's one complete cycle of the parent function of the sine. Now, let's goof with that. Let's throw in a b. So I'm going to go sine. Now, normally, like the way I had it written in the formula, trig of b and then parentheses of x, the graphing calculator is not going to let me do that. So I'm going to have to put the b inside, like here, for the calculator's sake. And let's see what happens. Now, the original parent function is going to be here in blue, and the new one with the frequency of 2 is going to be in red. Well, what I see here is basically this. In what normally took the regular parent function to do one cycle, which is from 0 to 2 pi, the new function actually did 1, 2 cycles of the function. In other words, when I had a frequency or a b of 2, what it did is it graphed twice as many cycles of the function on there, or it has a frequency of 2. It does 2 where the normal parent function does 1. Now, what else does that affect? Well, it affects the period big time, because if you notice, instead of going from 0 to pi to finish one cycle, it does it in half the time. So if frequency is 2, it cuts your period in half. So the period of the new function is just pi. Okay, let's play with it a little more here. What if I were to do something like that? What do you think is going to happen? Again, my b or my frequency is 4. What's going to happen? Well, let's find out what's going to happen. Okay, again, where it normally takes my parent function a period of 2 pi to do its thing, this thing now does 1, 2, 3, 4 cycles. That's kind of interesting in that my frequency is 4, so it graphs 4 times as many cycles of the function. What else does it do besides a frequency of 4? Well, it cuts the period into fourths. So instead of going all the way from 0 to 2 pi, it's actually done in 1/4 of that time, or in other words, its new period is found by just doing from 0 to pi halves. Okay? Does that work the same way with cosine? Let's find out. I'm going to graph cosine, and I'm going to make this a cosine, and let's do a 3x. Okay, here's my cosine. In the blue, the regular parent function starts at 1, then 0, then -1, then 0, and then back to 1. That's one cycle of the function. So how did that frequency of 3 affect it? Well, now it graphed 1, 2, 3 cycles of the function. It graphed it 3 times as frequent. What does it do to the period? Since b is 3, it cuts it into thirds. That's kind of the basic idea of what's going on with this. It, like the phase shift, affects the x values of your function. So in the next video, we're going to kind of talk about filling in this little table here. So probably a good thing for you guys to write down, and we'll start with that in the next video. I hope this gave you just a little heads up, like from a visual perspective, before I go through the algebraic perspective. I'll have video 2 posted in a little bit. Bye.